Hello, everyone. My name's Michelle Winters, and I am delighted to be here on behalf of the Data Engineer Things community, speaking to a lot of the questions that I've heard from community members over the past few months about how things are changing. And so I've compiled a list for our three esteemed panelists. So I'm joined here with Paul Ellwood, who is the head of data engineering at OpenAI, Laura Pruitt, who is a senior director of data engineering and data science at Netflix, and Vikram Koka, who is the chief strategy officer at Astronomer. Okay, so we're going to start with the most common question I have, the burning question on everybody's mind. Paul, are you actively working to eliminate data engineering jobs?
No.
Laura, are you working to eliminate data engineering jobs on your team?
No.
Vikram, are you working to eliminate the work that data engineers do?
No.
Okay. Now that we've got that out of the way, let's actually get into how things might be changing. So, Paul, you have decades of experience in data engineering leadership at some of the top data companies in the world, including Netflix, Airbnb, and now OpenAI. OpenAI is actively teaching models to reason about various tasks, including data engineering work. So my very first question, real question, is if AI can infer relationships, write code, and cleanse data on the fly, what is really left for data engineers to do?
Yeah, it's a great question. I could give a cop-out answer, which is, we don't know. But I don't think that's actually the right answer. I think we do have some confidence in knowing that data engineers are going to continue to deliver tremendous value, for the foreseeable future. A little anecdote is, I've never had more open roles on my team because demand for data engineering is so strong. And I'm at a company that's literally building the AI that's supposed to put us all out of work. I think the core value that data engineers provide, it moves to a higher level of abstraction. It's not just about the mechanics of building pipelines and debugging. It's really more about semantics, really nailing down what is the core definition here and making sure that that is reflected throughout the enterprise. Governance, making sure we understand our policies and that the AI is respecting those. Preventing drift, making sure that as we have AI agents developing code and people enabled to do whatever they want throughout the enterprise, that we don't actually lose sight of our core definitions. And then finally, ensuring trust in our agents. And so this is more of a systems sort of aspect of the role, but really making sure that what the AI is doing reflects what you want it to do, and if not, building the guardrails and mechanisms so that we get the AI to be trustworthy.
Great. And Laura, you sit at a very interesting place, which is at the intersection of the business and technology. So you have data engineers, data scientists, analytics engineers, and machine learning engineers on your team. So what is your perspective on how data engineering might be shifting?
Yeah, I agree with a lot of what Paul described, but then also emphasize the connection to the business as being so critical. So as the time spent on the coding elements of the role start to become less as a proportion, it's really about taking the technical skills that data engineers do bring to the table, their understanding of the deep semantics and the governance and what all these things mean, connecting that with the business, but also where AI is going from a technology landscape perspective, and building the data products that are really going to enable the business to move forward more quickly and with even higher quality into the future.
Okay, and this question's for all three of you. So if we were to fast forward 2 years from now, what new work has emerged, and what new work is almost entirely gone away?
So my perspective on this is that the intent and how you say that this is consistently being delivered has to continue to live with data engineers. because it is not only of what you want it to do, but how you know that it is consistently delivering that value as production AI applications. That it is, because fundamentally for production applications, they need to be reliable, they need to be fault tolerant, they need to be auditable. How did this come up with the conclusion that was actually delivered? And therefore, what is the right answer? And even if it isn't the right answer, how was this answer derived based on the data it actually took in as a model? That element which data engineer always had to do, whether it was like a report or a dashboard, which they had to do 10 years ago, but the same thing applies even in an AI world. How did the AI model come up with that particular answer? What is the inputs which it chose, what prompts, what data, what anecdotes, towards being able to deliver an auditable, verifiable answer continues to be a key thing, which absolutely data engineers have the discipline and the ability to do today, and they would need to continue to have years down the line as well. But the scope of tooling which they actually use, the scope of what constitutes how to get to that answer massively increases as a result of AI, LLMs, and the entire agentic framework.
Yep. And Laura, if we think 2 years into the future, what work is currently not being done on your team that you think data engineers might be well positioned to take on that would help the business?
Yeah, we're going to see more role expansion, I would call it, really for any person. I think when it comes to data, like the ability to access data and start to ask questions of the data and build on top of it, maybe products like those dashboards, I think it's going to become a bit more democratized. We've already seen a bit of a trend like that in the industry, but we should expect more of it. So kind of being able to understand what are those business consumption patterns that might be coming from new places, new partnership areas, technical or non-technical users, and being able to do all the foundational work that enables the right data to be part of the response when people use these tools is going to be super critical. And I think a lot of the work that didn't get as much airtime in some of the engineering functions in the past around documentation and really robust data quality, that is now absolutely, like you cannot operate without that. So that's going to be a lot more elevated and important, and it's actually the skill that data engineers bring to the table. So I'm excited for that to be like even more appreciated and valued and a bigger part of the role, because you're all data owners of the spaces that you own.
Paul, anything to add?
No, I think agree with everything there. I do think just there are a set of skills around, first of all, observing what the agents are doing, developing guardrails to ensure they're doing what you want them to do. And that can include, rules or evals, and then building the ability to steer, whether that's context engineering, whether that is fine-tuning the model or whatever. These are new muscles that I think that data engineers will need to build. I think all engineers will need to build them, but particularly for data engineers to really make sure that the trustworthy data is being served in the way you want by the agents. This is a role that DEs have to play to make sure that our data is being used appropriately.
Great.
The one thing I'd like to add to that is the evaluation part. Right? When humans are consuming data, there's so much of an element of they know what is right or wrong. When actions are being taken autonomously, it has to be right. And I think this is true not only for data engineers, but for all engineers, that the entire premise of test-driven development now needs to be absolutely turbocharged kind of going forward, that this is how you evaluate the response, how you actually put the guardrails is front and center, not an afterthought.
So Paul and Laura, there's a lot of data engineers I've spoken with who are very deeply skilled, basically software engineers who focus on data. And there is some concern that they might become glorified prompt engineers in the future. Do you see this as being the case, or do you see there being a space still for deeply technical engineers who are still contributing to Java or Python or systems?
It's a good question. One thing that this maybe is taking a slight step back, but one thing that I've observed is at OpenAI, sort of the awakening when everybody was like, oh my gosh, this is really going to change everything, happened in about December. And everybody in December was like, we're running 10 times faster. And then there was this dialogue about, oh, are we gonna have jobs in March? You know, like everybody was just really anxious because they could see the power of this technology. But the thing we failed to recognize is that everybody was running 10 times faster. The product managers were running 10 times faster. The product engineers were running 10 times faster. Everybody was. Infra was. And so it really just transformed the nature of problems we were solving. So yeah, like maybe the person, going back to your question, maybe the person who was a master at writing like a pipeline perfectly, that skill is less valuable, and they will need to adapt to a different skill. But generally what we're seeing is there are emergent problems coming from the data volume, from the probabilistic nature of these agents and how do we build guardrails around them, that I do think that our highly technical engineers will just find a different set of problems to apply their like technical intelligence to.
Yeah, there will be a new set of distributed systems challenges. I think that's right. I had another thought and I lost it.
That's okay.
Oh, I mean, I don't know. In my experience, there's never, I'm never done with my job, and so there's also just this, you know, everything's somewhere within the range of the cut line, right? There's above and below, and I think what will hopefully happen is we're able to get more work done. Hopefully, it's more of the very still high impact work, but that's that acceleration that Paul's describing. As long as we're all kind of being lifted by the wave, then we should be able to produce more and maybe think a bit more creatively about what's even possible. I think that's the really thing that's exciting. The thing that's really exciting here is just, it's not just do what we do today a little bit faster and a little bit better, but like change the way we operate and the way that we partner. And I don't think we really fully understand what that's going to look like in the future, but I definitely sense some changes.
Right. So changing gears a bit, Vikram, Astronomer is known in the data engineering community for pretty much one thing and one thing only, which is Airflow. So I would first.
Well played. Very well played.
So I would first like to thank you as a member of the Apache Airflow PMC. The work that you've done in this open source community has been instrumental in driving the development and release of Airflow 3. And I think it's been an incredible improvement. I personally have been very excited to see a lot of the improvements, especially around DAG versioning and some of the other things that you're doing. But I want us to think a little bit more about orchestration, and as it becomes more autonomous, should we be still optimizing for DAGs, or should we start optimizing for intent?
I actually think both. I don't think it's actually a choice of either or. I think it is really two different layers of how you define the problem and who operates at what layer. Right? So I think intent is what the business user would really want to see and be able to express it, hey, this is the problem I want to solve. Okay? The expression of that intent eventually becomes a pipeline, which does need to be executed in a production workload. So an example of this is actually just the other day, I was looking at the Airflow survey data, about 6,000 entries and about 160 questions or something like that. And I was actually trying to profile what is the environment of somebody who's been using Airflow for AI. And I gave that as a prompt. The LLM generated the pipeline for it, which involved 4 different questions, 4 different SQL queries, which are actually run on the data. Gathering the data from those 4 different queries, synthesizing the answer of collecting all this data, and then coming up with the answer saying, hey, this is the typical environment of somebody using Airflow for AI. That was done as a pipeline, wherein it was gathering information, first figuring out what information to gather, then creating the queries to gather that information, running those queries, in this case, using data fusion on that particular set of data, running those queries, gathering the data, 4 different elements of query running, giving all that information back to an LLM to synthesize that particular data and come back with an answer, and then being able to evaluate it, ideally, before coming up with that answer. Right? So, very simple prompt. My intent was very abstract. The execution of it was a pipeline. And I think that's the reason why I say it is actually built. That from a business user perspective, it is really about, you'd like to operate purely at the intent level. From someone who wants to have this run reliably in production with real quality and saying, hey, are the guardrails present? Not necessarily implement all of it, but are the guardrails present? Is this efficient? Am I making sure this is reliable because it's running multiple different queries across multiple different systems? That implementation is a pipeline, and that's why I actually think it's built. And both of them are important. It is to say, hey, only one or the other is a false choice at this point in time.
That makes sense. But I do want to dig a little bit more into this idea of intent. So if we were to have an intent-based system, what is required in terms of metadata and lineage and governance that does not exist today?
So again, I think the precision, if it is purely intent-based, you lose precision. And that's why I think the pipeline, if it is observable with lineage, if it is basically retriable based on auditing, therefore being able to say, how did I come up with this answer? Those elements of governance, observability, metadata towards being able to drive the, hey, how did I come up with this answer? How am I actually running this? Is this running correctly because of drift of either new models or the data changes, right? I mean, that's one of the fundamental differences, I think, between software engineering and data engineering is it is temporal in nature. I mean, we wake up every single day kind of going, why did this stop running? And data changes. Right? So being able to have the pipeline to be able to handle these with these elements, and then to be able to detect the problems when changes happen, not if, when changes happen, being able to diagnose the problems is why I actually believe that both of these are equally important, that the expression of a pipeline with respect to observability and auditability, lineage, metadata, all of these elements of the constructed artifact, having an LLM translate the intent into a pipeline, then be able to make sure that the constructed, runnable, efficiently runnable artifact performs within these particular guardrails, which are observable, measurable, and auditable, is why I don't think it's an either or. But that's why I think the core elements are actually critical even going forward.
That makes great sense. Laura, Paul, any other thoughts on how we balance precision with flexibility of the systems?
I kind of think about a risk spectrum of just like can you identify where you are with that need for precision? And it might be really different depending on different use cases in different areas of the business and different consumers. So kind of having that as maybe part of that conversation, you figure out then how do we actually create it would be the one thing I'd add.
Yeah, and I agree, everything there. The one thing I would say is just there is a need to materialize metadata more, to have more explicit contracts between the interfaces of these systems that I think allows to cut through the sort of ambiguity of intent specification and say, okay, well, this is how we do things. And every time a pipeline is built, this is how it's going to be built because we've already provided all this context to the agent that's doing the building.
That was a great answer. And the reason why it's a great answer and not a good answer is because that segues into my next question. So let's talk about semantic contracts. Okay. And I just caught Dinesh's talk. He's from Amazon Web Services. And in his talk, he said you cannot orchestrate yourself out of a semantic problem. I love that line. So we're now talking about semantic contracts, but let's be real, a lot of companies are still struggling with data contracts, right? So can semantic contracts realistically be relied upon to prevent meaning from drifting as the systems continue to evolve more autonomously?
Is that a question for me?
It's for any of you.
I think the first thing I would acknowledge is what is a semantic contract, right? I think everybody talks about this mythical semantic layer, but it means different things in different organizations. But that being said, I do believe in this era where, again, there is 10 times the output, and anybody is empowered to do anything. Data scientists can ship PRs to change your most foundational tables. It's really, really important that we do have an explicit semantic layer that says, these are our core entities. These are the relationships between them. These are the materialized definitions for these metrics in code. And the need for that becomes more important because we're not operating at human pace anymore, right? Anybody can build a pipeline. Anybody can ask basically any question they want. And so having that common reference point and saying, these are our entities, these are the tables you should be using, these are the metrics definitions you should be using, becomes critical to sort of prevent the drift. And then, of course, that is a point in time answer. Then there's the challenge of a business transforming, right? Even at OpenAI, we used to have a chatbot, and we had this concept of a turn. But now, what is a turn in the agentic era where a user request can take 40 hours to be satisfied? And so we're now having to come up with new definitions, and I think the key is recognizing when the business is changing and the data engineers need to get in there and say, hey, our semantic layer no longer reflects reality. How can we get ahead of this? Because we have 500 people asking questions right now. And we really need the agents to be up to date on how we think about our business. And so I do think it does come down to that sort of materialization layer.
Anything to add?
It's super critical. Always was important and now is critical. I think seeing how a mix of humans and agents can help us with keeping that up to date, because it is really hard to manage that, right? I think we all have experienced that to some degree. So how do we also make that part of the job, which is so critical now, easier? And it's going to be a bit of a balance, I suspect.
Yeah, actually, I think Laura made a great point, which is, what is the mix of agents and humans to update it? Because it is, as Paul started, we're not operating at human pace anymore. And the amount of changes every one of us sees, even with just PRs on software every morning, is so much greater than what it was a year ago. I mean, just because of the ability of humans to kind of leverage AI, or AI automatically kind of creating fixes as well. And so how much can we leverage AI to help in keeping, first identifying if there is drift, and second, keeping it, if possible, as close towards, hey, this was my intent, and you need to flag this for attention, and then actually kind of being able to have a human help in resolving those differences is key for us to be able to operate at that new pace. Because I think everybody in this room probably has already faced it, right? There is a notion of cognitive exhaustion by the end of the day, which is happening a lot more now at the speed at which you're operating than it was a year ago. I mean, it is. I'll actually telling somebody I feel exhausted by 4 o'clock these days, and I never used to feel that a few years ago, but just the speed at which we are operating is, cognitive exhaustion is real far earlier in the day, I think, than it used to be for most of us.
For sure. I want to shift gears a little bit now to Laura. This question's for you. You do sit at this beautiful intersection between the business and technology. So let's think about data teams. They have historically optimized for movement and transformation. But in this AI native world, what are we now optimizing for? Is it speed, meaning, trust, business impact, or is it something else?
trick question because it's all of the above.
Yeah.
But
That is a business answer.
Good job. Good job.
if you have to prioritize, it's really, I mean, it's business impact at the end of the day. I mean, that's what we're all here to deliver. I think what I'm seeing is the speed feels faster now, and I want to make sure that the quality kind of matches with that, and that's kind of a lot of what we've been talking about here. And the business impact can show up in different, I think will be different ways, or maybe more ways in which data engineers are having impact in the future. I think a lot about the health of the data ecosystem that we're all working with, and how do we ensure that health stays quite high, and that we understand it, and we really treat the data that we own as a product, so that it really can be consumed by the agents, the humans, to really continue to deliver that business value. I mean, it's really the same job, but the ways that we're going to show up might just look a little bit different.
I love that answer. I want to call out the need to also maximize trust in the system. I do think that's something that at this point, we're already seeing it. Like, we don't know what the AI is saying to people when they're asking questions about DAO or growth or whatever. And I do think maybe in the past, I don't know that data engineers viewed that as much of their responsibility. Like, hey, we put these great assets out there and people better use them, but now it's like, actually, no, I think there's an explicit responsibility to ensure that not only does your good data exist, but that it is being used by the agents to give innocent data consumers the right answers. And so I do think that's a major mental shift that all data engineers need to think through is like, how is my data being used, and is the system that I am supporting trustworthy or not? And if not, what do we need to do to get it there?
On that note, what is a new optimization metric or signal that didn't matter before, but will define great data teams in the future? Is it around trust? Is it something else?
Yeah, I sort of was like, oh, that's a really hard metric to measure. So I'm trying to think of one that could be a little more concrete. But yeah, I think conceptually, any metrics that sort of point towards how well you're doing on the trust dimension, I think are where I would start.
Yeah, I think you can think about it as like, semantically, is it trust, is it quality, is it health? It's something about AI readiness, which I think will be in that phase for a period of time, and maybe eventually we kind of move past it, but just making sure the data is like, it's there, it's ready for whatever there is to come. And that is hard to measure, but having the mindset of that's actually what we're trying to deliver will help people, I think, take the right actions to ensure that health and that trust on the data, and then that translates to the needs of the business and the partners who are actually using that data.
Actually, I think both those answers covered it, to be honest. Nothing, those are brilliant.
So let's talk about when things go wrong. When an AI agent makes a $1 million mistake because it misinterpreted a semantic contract or something similar, who is liable? Is it the engineer who defined the metric, the platform that served it, or the model that reasoned over it? And we have a representative of each of those, by the way. So.
I'm going to not do multiple choice, but let me answer that question with an anecdote. We do a data sev review where, like, anytime there's a major data quality issue or a major data landing time issue, we review it as a team. And this past week, we had, I can't remember, it was 2 or 3 separate issues that were, Codex just did it. And it was like the human hadn't done it, the Codex had done it, and that caused the issue. And it really pointed to me to a need that we need to make sure that we have human accountability at the end of the day. And it's like, there's always an operator. There's always somebody who is responsible for the outcome of any workflow, any system. And if you don't have clarity on that as an organization, things fall apart really quickly. And so I think it is important that we know for each of these agentic workflows that are running all the time, and they may even be fully autonomous, like you don't even need to touch them, who is responsible for ensuring that that workflow, that system, that agent is trustworthy, and then like holding that person accountable when it's not.
So,
Yeah, go ahead.
Go ahead,
No,
Matt.
please.
So I was actually asking, I was relaying an anecdote to a friend of mine, saying, I grew up in India, and I was fascinated by woodworking. I had to take shop, right, in school, and those were hand tools. So I had chisels, like hand saws and stuff. Came out of this country, and when I started I got very much into DIY, and I was amazed with power tools. So I ended up buying a whole bunch of DeWalt's and Makitas and all this kind of stuff, and I had a blast kind of working with all of them. But with both of those, you get all the power and you get acceleration, but with the chainsaw, you can cut your leg off. Right? And I actually feel like that's the same thing with any kind of models. It's a tool. It gives you tremendous power, but as they say, right, the responsibility stays with you. You can't just say, hey, the model did it wrong. It's all based on how you prompted, what data you gave it, what context you gave it, and how you actually run it. So ultimately, I think it's human accountability has to kind of stay, as opposed to saying it is completely autonomous, because we're not really at that stage yet.
Yeah, I don't think we should be abdicating responsibility for the things we create and operate. But we should also just encourage the culture of the blameless retro. Things are going to go wrong, and that it is. And when they do, instead of reacting or overreacting in a way, just okay, what's going to help us prevent it from happening next time? What's the observability? What are the guardrails? What's the context we need to set? I think that will also go a long way, because it shouldn't be scary that we can make these kinds of mistakes, but we should just anticipate that they will happen.
But how do we ensure human accountability when the foundational models are essentially black boxes?
Yeah, they are black boxes, but there are tools that we have, like for example, logging, observability tools, auditability tools, context, and evals, and so I do think that, again, these are the sort of skills that I think workflow owners, and for data workflows, I mean data engineers who own these workflows, they need to have these tools in their toolbox, right? The model will do anything, and it's really important that you're developing the right prompts and giving the right context and writing the right evals and then making sure those are being observed. All of these sort of steps need to occur to ensure that you have a trustworthy model. And to Laura's point, that doesn't guarantee anything, and mistakes are still going to happen, and there's still risk. But I think that there's a lot of tools to steer these systems, and it shouldn't just be, oh, well, I let it rip and it did what it did, right? At some level, the data engineer becomes responsible for making sure that the guardrails are in place so that doesn't happen, And that is a sort of a new responsibility that didn't exist in the old world.
Anything to add?
I think it's the expression of how you define the articulation of the pipeline, right? I mean, you've got to be able to have those steps of the evaluation, and that's really what the intermediate step limits the black box effect. The ability to have those say, hey, this is not purely a one-shot.
Yes.
These are the discrete steps which are actually happening for this particular workflow. The model is getting called at this point in time with this context, with this data. The model kind of responded with these additional calls, which then invoke calls to these additional systems to kind of get additional data, and then it actually made the synthesis. That being able to break this apart into effectively what I tend to call a pipeline, but a chain of different independent, discrete, observable activities, really, really simplifies it from both the evaluation perspective and being able to have an effective retro, because then you have the information to know what went wrong in what step, or what data set got corrupted, towards being able to come up with an effective remediation and a fix kind of for the entire process. And I think that's what we've got to be able to kind of get back to, towards being able to design for that level of observability and evaluation in the course of the entire workflow.
So I'm going to shift a little bit here. We've talked about a lot of different things. We've talked about the future of orchestration. We've talked about semantic contracts. We've talked about evaluation of observability. All of these different aspects that might influence the data engineer's career. So as we think about the next 24 months, and this question is going to be for each of you, what is the one skill or capability that you would suggest data engineers invest in?
Do I get to go first?
Sure.
It makes it easiest. Just kidding. No, I would say, you said one. I would say semantic ownership and responsibility. And what I mean by that is really sitting with business stakeholders and understanding what they're trying to achieve, and then ensuring that that is materialized in the metadata, in the semantic layer, in everything I've been talking about, so that there is not ambiguity about what entities we're talking about, what metrics definitions are. I think really materializing the semantics and be an effective translator to the business is a critical skill that will not go away. If anything, it'll be even more important.
I'm going to pick flexibility and openness. Put them together. Technologies come and go. AI is certainly not a flash in the pan, but we used to be on Hadoop, and we used to write our ETL in Pig, and being able to learn new technologies and ways of working has always been a part of the job, and it will continue to be so. Especially in a place where the technology is so rapidly evolving. It's something new every week, it feels like. So that openness to learn and be curious, and the flexibility to not be frustrated when things are moving really quickly and you hear different things from different parts of the industry or from within your own company, I think is quite critical. So that's something I would encourage people to take.
So this might sound a little bit weird because Paul picked one, Laura picked two. I'm going to pick three. But it is in no particular order, because I can't actually because I think Laura made the comment, it depends on what your business is like. I actually think data engineers have been really experienced at building reliable, auditable, fault-tolerant pipelines over the years. And I would encourage them to continue focused on reliable, fault-tolerant, auditable, agentic workflows, and be able to define them in a way that leverage your skills, which you already have, expand the skills towards being able to, as Laura said, it's a new technology, adapt and being able to increase the technology, but be able to define the principles for those production AI workflows to be fault-tolerant, being able to audit, being able to retry. Now, which one of those is more important is going to be different based on the business context. Financial, regulated industries, you might say auditability is more important. In other contexts, you might say fault tolerance is more important than auditability, and that is truly based on the business context. But being able to define the systems for those three perspectives and continue to define things for those three perspectives, regardless of whether you're actually using a model for parts of it or for its entirety, because LLMs are great at generating code even, but then make sure that it actually fits these particular elements when you're actually running production AI workloads, I think is actually why I'm actually really excited for the future of data engineers. Honestly, I feel like this is a great time for to be a data engineer, because you can really expand your skills and be able to be very, very key in how agentic workflows actually get deployed to production.
All right, last question. I am going to ask all of you to take off your corporate hats for just a minute. And Vikram, I'm going to ask you to put on your open source contributor hat. All right, there's a lot of conversation right now around what AI means for humanity. What can data engineers, the people in this room here today, do to ensure that the future of AI aligns with the well-being of humanity? First one to you, Vikram.
I think it's really, to me, fundamentally, right? I probably haven't had this much fun writing software again, right? Which is, again, like having gone up, I used to write a lot of code myself, and being able to, but I stopped writing a lot of code because of like, you kind of get into management and you end up writing less code. But now I'm having a tremendous amount of fun writing code again because it's a higher level of abstraction. And so I think there's a huge element of fun, but there's a huge element of risks for humanity at the same time as well, right? I think it is very easy for us to kind of get into the stage of, hey, we're kind of getting over our skis at this particular point, but being able to realistically leverage and be able to kind of say, how can we do something better individually as well by leveraging this, is how we can approach this kind of going forward. I mean, this is the kind of the same advice which I tend to give my kids, right? Is, this is a new tool, how you adapt to it, how you grow and leverage this while being aware of the pitfalls of actually kind of getting over-dependent is personally how I would actually approach this.
Laura, same question.
It's a good one. I mean, some people here may be working on products or at companies that kind of explicitly have this as their mission, which is great. I think it's at the individual level, if you see something, say something. If you're seeing something being built or a part of the product that just doesn't quite sit well with you, raise it and have a conversation about it. And that's probably a way to help distribute that out so that we can make sure we're heading in the right direction.
All right, Paul, you get the final word.
Okay, yeah. I mean, I think that, a lot of us are either in companies that are building AI or like implementing AI into workflows. And so I'm trying to think about what can we do distinctly as data engineers to sort of help with this mission that you described. I think the big thing is actually really leaning into how do we make the AI's behavior observable, right? How do we take all of this like exhaust of what these agents are doing and transform that into sort of like useful data outputs that we can observe? Is it doing what we want it to do? Is it acting responsibly? And helping the rest of the company or whomever you're concerned about get the information they need to steer the AI in the direction we want. So I think we as data engineers, our magic is taking giant amounts of data and turning it into something useful and actionable. And if we apply that to agentic behavior, we can help ensure that we as humanity understand what AI does and hopefully have a chance to push it in the right direction.
Thank you for this conversation. Please join me